The Peterborough Return of Infrastructure Collaborative Project. I'm Victoria.
I'm Alex.
And I'm Andy.
Welcome to our presentation.
So we'll be using these pictures of ourselves to represent who will be talking for each of the slides. So for example, I'm Andy. I'm an application specialist.
I'm Victoria. I am a cartography specialist.
And I'm Alex Willett, and I am an application specialist.
So we are doing the Peterborough Return of Infrastructure Collaborative Project. Just a little bit of background information on infrastructure. So infrastructure plays a very important role in the city's social and economic development. This looks things such as services that are roads, transportation, sewage, anything to pretty much keep a city functioning. All these services require maintenance, however, and so the city allocates money from different areas in order to keep up with maintenance. The city is working with a company called Urban 3 right now, which is the picture that is on this slide. Essentially, they use spatial analysis to take tax revenue from different properties and different developments within a city, and they allocate it to different areas of infrastructure such as road maintenance or transportation or sewage, and they see how much money a city is making in certain properties and certain developments, and then they compare it to how much they actually need to keep up with maintenance.
Problem definition. So we'll be looking at how the city uses its funds by determining which types of infrastructure are a net gain or loss for the city. The revenue that the city makes based on property tax and the use of those funds on infrastructure maintenance. We'll be exploring whether the city of Peterborough is losing funds to maintenance or if they are gaining profit from the taxes.
So the city of Peterborough, when looking at previous work done in this area, actually has not done any previous work. Essentially they have different budgets and they have different data sets that show how much money that they make off of taxation, or if they're making a net or loss gain. And they also have how much it takes to produce infrastructure and to maintain it. However, they actually haven't done a spatial analysis of it. So this is where we come in. And we'll be working with mainly one client, Owen Andrew Simmons, but also along with Michael Papadakos. So Owen, for starters, he was a GIS Fleming graduate back in 2017, I believe. He is a GIS technologist for the city of Peterborough, and he is head spearing this project right now. He is taking all of Michael's dreams and turning them into a reality. So a lot of what they're doing and what they're looking at is the Urban 3 and how they analyze their data. They want to bring that to Peterborough without actually having to hire Urban 3. So Michael is the Director of Asset Management in Peterborough, and he is head spearing the aspects of all the infrastructure, and he has all the vision. Owen, along with us, are just trying to come up with a solution and something that we can work with them.
So essentially, the main objective of the city of Peterborough is aiming to understand whether an individual property is a net gain or a net loss on the city's budget in connection to infrastructure maintenance and property tax revenue. The goal of this project is to take multiple factors into consideration to gain an understanding of various infrastructure costs and to take into account the impact of infrastructure costs in connection with urban sprawl and in comparison to new or traditional high-density development styles. The client must understand how current and future developments will affect the city's finances before they are built and wants to learn how to use various land use types sustainably. They also want a progressive approach to distributing the cost of a single asset class across residential and commercial properties in the city. On the right here is a table of the objectives we have to do and the academic resource that it will fall under. So for example, there were certain categories of spatial analysis, cartography, web development, and we highlighted what each task we're doing, what academic resource or academic section it will be highlighted under.
Some of the services that we'll be providing are a Python script, ETL workflows to process data for further analysis. We'll be doing a network analysis to calculate service areas, and spatial analysis that will be used to calculate the snowplow costs and the sewage costs. Both of these analyses will be done in ArcGIS Pro.
So when we start out, we get the raw data from our client, like their client gives us, and it's gonna be pre-processed before any type of analysis is performed. This includes cleaning up attribute tables, removing any unnecessary data tables, renaming fields, join different layers, etc. And then once that pre-processing is done, there will be two different types of spatial analysis that will be performed. The first one is a network analysis to determine how much the city spends on sewage costs for each property. This will be determined by creating service areas around each sewer manhole, creating a pipe network, and using the trace network tool to return selected properties within that service area network. Then, based on the properties that are selected, the cost of each pipe can be divided among the total properties. The second analysis that will be performed will calculate the total cost of snow removal. This will be determined by multiplying the operation cost per kilometer, the length of the road, and the number of lanes on the road. Additionally, depending on if the road is an arterial road, salting may be an additional cost that will be added to need to be added to the analysis. And once the analyses are complete, a paper map will be created by our group cartographer to show both types of analysis using the City of Peterborough's cartographic standards. The cartographic output will be created before the automation will be complete so that we can determine what symbology fits each layer the best. While that final map is being created, two Python scripts will also be created, one for the sewage analysis and one for the snowfall analysis. Using the ArcPy geoprocessing tools, the scripts will essentially modify the workflow that was created manually on ArcGIS Pro. ArcPy documentation from online Esri will be a huge resource to complete these scripts. The finished scripts will include changes to the symbology to create a map output from the script. And then after all those deliverables are complete, or I guess services, all layers will be shared to ArcGIS Online as a web layers and created into a web map. The web map will then be integrated into a dashboard and added to a story map with supplemental text as one of the final deliverables.
So some of the resources and requirements that will be needed for this project. For the software, ArcGIS Pro will be used for the analyses. VS Code will be used to automate the scripts that we performed in ArcGIS Pro, and ArcGIS Online, Story Maps, and Dashboard, which will be used for the final deliverable outputs. For the data resources, all of our data will be provided by the City of Peterborough. For the hardware, we are going to be performing many of the processes from the client's computer, which he has called the supercomputer. All of our work will be done at Fleming College, on Fleming College computers, and any external work will be done using personal computers. External hard drives will also be used to store any external files and meetings and data for the group.
So along with any project, there are some risk assessments that need to be taken into consideration. And so our team came up with 4 different risk assessments that we rated based on if they were likely, unlikely, very likely, or somewhat likely. And just went through them each. So the first one is the client supercomputer not being able to process our whole data set. So we are working with large data sets, and although it is a supercomputer and they highly suggested that we come in and use that supercomputer, there is always the opportunity that this supercomputer is not going to be able to handle our data set. So we rated this somewhat likely. It is a very powerful server on that computer, and so we don't expect this to happen. However, there is a possibility that this is going to happen. The second one is the client leaves the project. We rated this very unlikely just because we've now met with the client in person and over meetings, and we find that he is very passionate about this and wants to take the steps towards finding this for Peterborough. However, there is always the opportunity that some unforeseeable event happens that he's unable to continue there, and so we did put this as very unlikely. However, there is the possibility. The next one is a group member leaving. We rated this very unlikely as well, only because we are very passionate about this project as well, and we all want to succeed in it. However, along with the client leaving the project and something unforeseeable happening, that also falls under the same category with one of us. The last one is ArcGIS processing tools malfunctioning. Unfortunately, this seems to be something that happens quite often, and so we've rated this very likely just because of the nature of this processing tools. And so, yeah, we rated that very likely just because of how often things happen. So next is the literature review. So based on the literature, we found 3 common themes. These are urban sprawl, sustainable development, and multi-criteria analysis. So looking at urban sprawl, this is the most common development in North America. It is all over North America. Pretty much every city sees some form of urban sprawl. And it is very much a very multi-dimensional issue, meaning that there are so many layers to it. So many issues that are brought into urban sprawl, and so it causes economic stress, it causes automobile dependency, and other various issues. When looking at sustainable development, or in another term, traditional high-density development, you see more, again, high density, high walkability, low automobile dependency, there's not as much economic stress, and it always creates a higher tax revenue. So in a lot of cases, when we've been looking at and doing research, it has shown that urban sprawl, such as maybe a Taco Bell or a Walmart, or very sprawled out development patterns, cannot create the same amount of revenue at the beginning of their life than traditional can at the end of their life. And so it just shows that the tax revenue created from sustainable or traditional development is always going to be higher than something that's sprawled out that's not producing as much revenue. So the last thing that we found in these are multi-criteria decision analysis. So it's analyzing multiple factors at once. And like I said, going back to urban sprawl and sustainable development, they're multi-dimensional issues. There's so many factors playing into it. And so being able to analyze them all at once in a multi-criteria decision analysis, you get to input everything. And so infrastructure analysis is also multidimensional. So when taking out and putting in urban sprawl and infrastructure analysis and sustainable development to understand these things, using multi-criteria analysis is a very important aspect.
So in conclusion, return on infrastructure is a crucial aspect of the city's economic and social well-being. Careful planning is necessary if the city wants to return positive for the investment on infrastructure, and is equally vital to preventing urban sprawl patterns. The city of Peterborough can track their investments, adopt sustainable strategies, and make informed decisions on the infrastructure investments. Ultimately, this will improve the quality of life for the residents and help Peterborough save money.
Thank you for watching our presentation. We hope you have a great day.